So this is the 2016 Lch Higher Level Paper 2 and we're looking at question number 1. The points A, 6, minus 2, B, 5, 3 and C, minus 3, 4 are shown on the diagram. So here we have A, B and C. Find the equation of the line through B which is perpendicular to AC. Okay, so we're looking for the equation of line through B that's perpendicular to AC. So that would be a line from B perpendicular to AC, so something like that. So that's the line we're looking for. And obviously then if you're to stretch that line out, it would be something like so. So we're looking for the equation of this line. Well, we know that this line here is going to be perpendicular to that one. So if we find the slope of AC, then we'll be able to find the slope of a line perpendicular to that. So the slope of AC is equal to subtract the y's over subtract the x's. So if we have AC, we can call this x1, y1 and this x2, y2. So the slope is y2 minus y1 over x2 minus x1, and this formula can be got in your tables book. So that's equal to y2, which is 4 minus 2. So 4 minus 2 all over x2, which is minus 3 minus x1, which is 6. And when we do this in a calculator, that gives us 6 over minus 9, which is minus 2/3. Okay, so that's the slope of AC is minus 2/3. Well, if the slope of AC is minus 2/3, well, the slope of this line here would be the flip of this and change the sign. So if you flip this fraction upside down, so the slope of this line will be equal to, instead of minus 2 over 3, it'll be 3 over 2. So you flip the fraction and change the sign. So that's a slope of 3 over 2. And we know it goes through the point B, this point here. Point B is the point 5, 3. So now we can just substitute this slope and this point into the formula for the equation of a line, which is y minus y1 equal to m bracket x minus x1. And again, this formula is in your tables book. So we're going to substitute, this time we can call this 5 is going to be x1 and 3 will be y1. So y minus y1, which is 3, is equal to the slope m, which is 3 over 2, bracket x minus x1, which is 5. So that's the equation of our line, so we can just tidy it up now. Y is equal to 3. Best way to tidy this up would be to multiply across by 2 first of all. So that will give you 2y minus 6 is equal to 3 bracket x minus 5. Because when you multiply the 3 over 2 by 2, it just leaves the 3 on top. So that gives me 2y minus 6 is equal to 3x minus 15. So now you can just bring the 2y over here, becomes a negative 2y. And the minus 6 over here becomes a positive 6, leaving me with 3x minus 2y minus 15 plus 6 is minus 9 equal to 0. So that's the equation of the line. Okay. Part B says use your answer to part A above to find the coordinates of the orthocenter of the triangle ABC. Well, the orthocenter is the intersection, this is the orthocenter. Orthocenter is the intersection of the altitudes. So a triangle has 3 altitudes and they all intersect at the orthocenter, but you only need to show where 2 of them intersect to find the orthocenter. Okay, so we have one altitude drawn here. So from a vertex of the triangle, if you draw a perpendicular, that's the altitude, that's the height of that triangle, with AC as the base. Now, if we're trying to find, if I just imagine continuing this from the line C, if you continue that line out there to there, well, the altitude then from A would be perpendicular to that continued line, and it's going to intersect with the other altitude up there somewhere up there anyway. So the point we're looking for is this orthocenter. So sorry, just so we don't get confused, that's the slope of the line there. That was just the slope of that line. So we're looking for this point here, the orthocenter. Okay, so, well, we have the equation of the black line here. We've already found that. That's 3x minus 2y minus 9 is 0. So if we can find the equation of the red line, and then we'll have 2 equations that we can solve simultaneously to find this point of intersection, the orthocenter. Okay, just label this there, orthocenter. Always a good idea to draw a sketch or a diagram to show your understanding. So, to find the equation of the red line, I'm going to need the slope. And I already know, well, I know that it's going to be perpendicular to this line here. So if I can find the slope of CB, I'll be able to find the slope of the line perpendicular to it. So the slope of CB or BC, so B is 5,3 and C is minus 3,4. So B is 5,3 and C is minus 3,4. So the slope of BC is equal to y2 minus y1 over x2 minus x1. So if I call this x1, y1, and this x2, y2, and substitute those in, that's going to be 4 minus 3 over minus 3 minus 5. And that gives me a slope of minus 1/8. Okay, so minus 1/8 is the slope of this line here, BC, minus 1/8. That's the slope. So the slope of the red line then, this line here, is going to be minus 1/8 flipped upside down with the sign changed. So the slope of that will be 8 over 1, which is 8. So that's the slope of the red line. Okay, so to get the equation of the red line, well, I know it goes through the point A, which is 6 minus 2. So going through the point 6 minus 2 with a slope of 8, the equation will be y minus 6 minus 2. So y minus y1, so y minus minus 2 is equal to 8 bracket x minus 6. So that gives me y plus 2 is equal to 8x minus 48. And when I tidy that up, bring both of these over here. That's going to leave me with 8x minus y minus 50 is equal to 0. Okay, so that's my equation of the red line. So now I have the equation of the red line and I have the equation of the line BC. So now what I'm going to do is, I have the equation of the line, the black line here. So now what I'm going to do is solve them simultaneously. So 3x minus 2y minus 9 is 0. So I'm going to do this over here. 3x minus 2y minus 9 is 0. And then I have this one here, which is 8x, minus y minus 50 equals 0. Okay, so I'm going to double, if I'm going to solve these simultaneously, I'm going to double the second line so I get minus 2y as well. So I'll rewrite the first line, it's going to be 3x minus 2y. I'm going to bring this minus 9 over the other side, make it a positive 9. And then I'm going to double everything here, so it's going to be 16x minus 2y. I'm going to bring this minus 50 over there, positive 50, and then I'm going to double it, which is 100. Okay, so now I have the coefficients of y is the same, so if I want them to eliminate, I'm going to subtract. So I'm just going to subtract upwards. So I've got 16x minus 3x is 13x. Minus 2y minus 2y is 0. And I have 100 minus 9 give me 91. Okay, so let's see. If 13x is equal to 91, you can divide both sides by 13. 13's cancel here, so x is equal to 91 over 13, which is 7. So that's my x coordinate of the orthocenter. And then I'm just going to sub that back into one of the equations. So I'm going to sub it back into the equation of the first line, which is 3x minus 2y equal to 9. So that's going to become 3, replace the x with 7. 3 7s minus 2y is equal to 9. So that's 21 minus 2y equal to 9. Bring the minus 2y over there, becomes positive. Bring the 9 over here, becomes negative. So 21 minus 9 is 12. And that's going to be equal to 2y. So now divide both sides by 2. Leaves me with y is equal to 6. So the orthocenter is the point 7, 6. And if I go back to my diagram, I can see 7, 6 would be roughly here. So it's roughly what my rough sketch, it's in the right position. And that's the end of question 1.